when you're dealing with equations of lines, you're talking about what's the equation of the line that's on the xy coordinate plane. Those are fancy terms for it's on graph paper. Okay? And what happens is last hour or in the second hour, people were forgetting some simple things. You have an x-axis and a y-axis. You guys vaguely remember that? You had what were called ordered pairs. That ordered pair was what we would call a coordinate. What value came first? The x-coordinate came first, okay? So you had the x-coordinate, and then you had a y-coordinate, the corresponding y-coordinate. Now, your xy coordinate plane, your grid, if you will, is broken into 4 parts. Remember what those guys were called? Quadrants, okay? First quadrant, second, third, and fourth. They went counterclockwise. Vaguely ring a bell? Now, in each quadrant, your x and y values were either positive or negative. What were they in the first quadrant? They were positive, positive. Good. In the second quadrant, it was negative and okay, cool. Now, one of the things that we deal with now with this coordinate plane system here is that, when you come back a year and a half from now, when it's the middle of February, March next year, when your Algebra 2 class is learning about trigonometry, you'll remember this coordinate plane system, positives and negatives, because as you get into trigonometry, if you guys did, I'm sure you did a little bit where sine, cosine, tangent, those little buttons on the calculators and stuff. So what comes first in the alphabet? Sine, cosine, or tangent? Oh, you never did? But you know the buttons on the calculator says sine, cosine, tangent. S-I-N, C-O-S, T-A-N. What comes first in the alphabet? Cosine. Yes, A. Thank you. Yes, I'll give you that. But of those 3 values, what comes first? Cosine. What comes first in the alphabet, X or Y? X. In Algebra 2, if you remember nothing from your geometry class, please remember the fact that cosine is your X value, sine is your Y value. It's why trig trigs. You don't need to know that for geometry, but it's why you need to know that for Algebra 2. It'll be a very helpful hint in a year and a half from now. So when you walk by my room, and don't flip me off, be nice. But if you do walk by when you're learning that stuff, you say, "Hey Murphy, you were right. Cosine is your X value." Like, duh. You'll be very happy you heard that. Sine will be the Y value. You don't need to know that now. I'm just saying that every time I say stuff like alphabetical, there's reasons why I do that, and that's kind of one of the things that we show. But anyway, so you've got positives, you've got negatives, and everything like that. We also learned about this. This is this again. And the reason, whoa! So when you're dealing with slopes, you guys dealt with this last year in your algebra class. If you've been dealing with slopes for a long time, and like you just said, slopes was your change in y or change in x. Have you guys ever seen it written like this?
No.
That triangle represents the Greek letter delta. We're not doing that. Close it. Doing math. That's not your math notes. Put it away. Thank you. This one and that one does, yes. So that triangle stands for the Greek letter delta, and it's, in math it stands for change. Now, when you're dealing with slopes, you had to have sets of ordered pairs. And what we would do is we would denote them with what are called subscripts. X sub 1, Y sub 1, X sub 2, Y sub 2. Those subscript values just stand for first set of ordered pairs, second set of ordered pairs. It's just like a grouping, a way of keeping them straight. Okay? That way we know what we're dealing with. But then when you found the actual slope, we said it was the change in y divided by the change in x. And what letter did we use to show slope? What constant letter did we use? That's slope-intercept form, but the M stands for slope. Do you know why they use the letter M? Because it looks what? Well, think of this. What do you use A, B, and C all the time for? Yeah, use triangles A, B, and C. A squared, B squared, C squared. Pythagorean theorem. Letters. Yes, they're also letters. In math, what is D always used for? Diameter, distance. Do you guys ever know what an E is used for? Exponent. Yeah, there's what's called an exponential function. E to the x. Principal rate, principal interest, things like that. You use the value E. There's a button on your calculator that says E. Kind of. F, G, and H, they're used all the time for what's called function notation. F of x, G of x, H of x. Those are the ones that use that all the time. I, you know what I is for? I is an imaginary number. Yeah, this is the thing called an imaginary number. So yeah, there's twice as many numbers than you really think you do about. There's all the other imaginaries. That's something you'll deal with in algebra 2. No, not cajillion. No, but you use imaginary numbers. J and K. J and K, you might have used J and K last year when you first learned about slope. They taught about slope in terms of what's called direct variation. You guys vaguely remember that terminology? Well, some Algebra 1 textbooks, use K as a constant of variation is what they call it. J is used as, in Algebra 2, you'll use this again. It's called a joint variation. It's when you have multiple variables that lead towards the same product. It's a lot of weirdness to it. Now, L is used, looks like a line and a 1. And then they got down to M and like, oh, we haven't used M yet. So they used M. Remember, math people make stuff up to make their lives easier. That's what we do. It's not like a really cool story, but that's what it is. Anyway, slopes. How many types of slopes? Oh, by the way, I just made all that up. How many types of slopes are there? M comes from the Greek word modulus. Modulus is change. That's where it comes from. It has nothing to do with that. Yep. It's fun. Remember how I said there's 80%, 8% of the stuff I tell you is true, 20% is made up? You got to figure out what's which.
Come on.
No, they're not. So there are 4, again, this is something you've seen. There are 4 types of slopes that you have dealt with. What's one of them? Positive. Good. You're thinking of the equations for mx plus b. So you got positive, which means you have, okay, so we have a positive slope. We have a negative slope. What is it? All right, let me ask you this. I'll set you up for a good one. What's halfway between positive numbers and negative numbers? Zero. Zero. You have a zero slope. Not 0. You have a 0 slope and you're undefined. So you've got 4 types of slopes that you guys have all dealt with before. If you're dealing with a positive slope, what direction is it moving? Up. And? Down.
To the right.
Thank you.
Yes, it was.
Positive slopes on graphs move up and right. Okay? Yeah, it's going up and right. It goes up and right. Or what's the opposite of up and right?
Down and left.
Down and left. And the reason why that works, if we go back to when you're in your quadrants, Slope, as you know, is change in y over change in x. So if y is positive change and x is a positive change, what's a positive divided by a positive? Positive. What's a negative divided by a negative? It's a positive. That's why these guys are positive. Okay? That's why that works. Correct. Well, up and right is the same thing as down and left. Come on now, we have a lot to do. And then negative goes down and right. Yep. And I always, when I'm talking about positives and negatives, I always say up or down first, whether it's positive or negative. If it's positive, I say go up. Then my next step is always to go right. If it's negative, I go down first, and then I go to the right. Because up and right is positive, down and right would be negative, or the opposite of down and right is up and left. Another reason why a lot of times I talk about the opposite directions, down and left, up and versus up and left, is sometimes when you graph things, which we'll spend most of our day tomorrow graphing, you may run out of space on a graph paper or what you're working with. If you're going up and right, you only maybe go one slope piece, so you have to go backwards the other way to make another dot to draw out the whole line. That way you guys remember what the opposites are for the directions. Okay? Zero slopes. What kind of lines have zero slopes? Horizontal, good. Horizontal lines are the ones that have zero slopes. Easy way to remember that. What's the second letter of the word horizontal? O. And it looks like a zero. Nobody said hope. Anyway, back to this. When you have a horizontal line, we've said it before. Anyway, horizontal lines have a slope of 0 because what never changes? Well, yes, it doesn't change. Slope never changes. Slope is constant no matter what it is. Whoa! Guys, stop. If you have a horizontal line, if I have a horizontal line, okay, what doesn't change? Why? I didn't hear you. You gotta be louder. Everybody else around you is louder. I'm trying. So y values never change. Y values for a horizontal line, the y value is constant, which therefore means that the equation of the line is always be y equals a number. And if you're looking at slope, yes, I'll help you talk louder. So the equation of every line that's horizontal is always y equals a number. When you do slope for it, it's 0 over some value of x. Okay? When you have 0 in the numerator, your answer is 0. Okay? On the other hand, when you have an undefined slope, that means you have a vertical line. If horizontal lines are always y equals a number, vertical lines then would be, it's nice when you have process of elimination, isn't it? And we always say the undefined slope is because the x value never changes. Yes, ma'am?
Okay, this is like, is that like a hint that
For what, when you're doing slopes or when you're graphing them? Okay. So if y equals a number, if the graph is y equals a number, the easiest thing to remember, let's say y equals -4. Okay? And we're not, like I said, we're not graphing today, so don't worry about this today. But if you had to graph y equals -4, well, what I want you to think of, where is y equal to -4? Well, here, 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 could be over here. You see what I'm getting at? It means that at every point, no matter what x is, y is going to get -4. Think of it that way. Okay, what's your question? Oh, the horizon. When you look out the horizon, which way does it go? Yes. Oh, yeah. There you go, sir. All right. That's, ladies and gentlemen, come on. We don't have much time. Yeah, that's the easiest way to think of sunrise, sunsets on the horizon, left and right. Okay? Now, when you're finding slopes, remember, you're just basically filling in the blanks to the equation for doing so. For example, if I wanted to find the slope between these 2 points, and obviously for the first few days of doing this stuff, I really want you guys to make sure you write out a couple of things that we are not going to screw something up. We know that we have an ordered pair of 4, -6, and then 7 and 2. My suggestion to you guys is to literally label everything as you are writing them out. First x value, first y value, second x value, second y value. Because now, when you go to fill in the formula for slope is change in y over change in x. Guys, you fill in the blanks. Okay? Yes, ma'am.
Why does it change the y factor?
Because it's rise over run. Rise is the up and down. Run is left and right.
I remember that.
Yes, ma'am. Because it's rise over run. Rise are the values that go up and down. It's the y values. Runs are left and right. It's the x values. So you fill in the blanks. 2 minus a -6 over 7 minus 4. And one of the main reasons we keep telling you guys about these multi-view calculators, because there's a fraction bar. You can type that in exactly like that. It'll simplify the fraction for you if need be, and you're done. It does it for you. And there's your slope. You're using the equation to get you there. You're going to be using it a lot now. Slope. Okay?
What did that say?
Same thing as the equation for slope. Now remember, when you do these things, we got a handful of these today to practice through as we go along. Write out the equation. The more you write out, the easier it gets. Yes. That's what it should be. Yeah, mixed numbers do not exist. You don't want them. You can't walk the slope of 2 2/3. You can walk the slope of 8/3. There's only one other time. There's only really going to be like 1 or 2 other times in math in high school that you'll ever use a mixed number for. Again, they're just pointless. Yes.
I got 2 questions.
One.
Okay, one of them is, so like, we're just learning about slopes today, that's all we're learning?
No. Second question.
Do you want to join this movement I made where we blow our G's up to our nose?
No. But thanks though. If I wanted to roll my jeans to my knees, I'd wear shorts.
Yeah, but it's not moving
Brian, no one's gonna follow it.
Are you gonna tight roll too, or what?
though. No, I'm just.
Why you gotta shut it on me, bro?
Cause I got a mosquito bite on each edition. That's why.
Mosquitoes be biting jeans.
They were really bad last night at our baseball game. So
Yeah,
yeah,
it's like the apple orange. It's like raining on me. I was running down the aisle with my pencil.
Oh my god, please no.
Yep. Slope intercept form. Guys, we got a lot to finish out here, otherwise you're gonna be on your own to figure it out. Slope intercept form. Slope intercept form was the most reliable way that we wrote out equations that were linear. And what I mean by linear is just y. What is the equation? Y equals mx plus b. Okay. Y equals mx plus b is that generic form that we call slope intercept form. It is very useful for graphing. Because when you have a slope intercept form, you know what your slope is, the m value, and this b value is your y-intercept. Remember, your y-intercept is where it goes up and down. That's where you start your graph. So your m is your slope, b is that y-intercept. Okay? This form was kind of the same way that we would always go back to. We set it up. Whatever equation we were working with, we would finalize our answer into that format because it was more of a standard way of doing things. We also like y equals mx plus b because as you get into algebra 2, there's a button on the calculator that says y equals. No, it just says y equals. So, for example, let's say you have a slope of negative 2/3 and a y-intercept of -5, what would your equation be? What does the m value represent again? Okay. And then what does the y-intercept represent? E. Put it together. What do you get? Y equals -2/3 x minus 5. And you're done. Go on your merry way. That's what you do. Now, when the reason why we use slope intercept, and again, we're not graphing today, but when we start graphing things tomorrow, we know that you would start your graph at -5, and you would walk your slope. If your slope is -2, what do you go first? Down 2, right 3. The opposite of down and right is up and left. That's why we did it that way. That's why I show both values, up and right, down and left. I flip-flop them around and make sure we all work out. Okay? But not always are you given your intercepts right off the bat. Sometimes you have to worry about something like this, where you have a slope of -2, and you have an ordered pair. Write the equation on the line that has that slope and goes through that point, which means you had to use a different form. You had to use that form that was called point slope. Okay? Point slope is for this exact time. Gentlemen, I'm done telling you to stop talking. Thank you. You use it for this specific moment when you have a point and a convenient. What happens here is that you're given an ordered pair. We would label them your only set of ordered pair that you have some x sub 1, y sub 1, just like you would do it done before. Then you have this point slope form. Y minus the y sub 1 slope x minus x sub 1. This is more of what we would call the working man's version of slope intercept form. The reason why we like to use this one is because you can substitute and then solve for y. Okay? Now, the reason I always use this point slope form for just about everything is because it's very user friendly. Next week, Monday and Tuesday, we'll be spending time writing equations of lines that are parallel, writing equations of lines that are perpendicular through specific points with specific slopes and whatnot. And we're going to keep coming back to point slope form. So what we know here is y sub 1 is 4. My slope is -2. My x sub 1 is -3. And anytime I have minus and negative, there you go. I switch it to a plus.
Wait, what?
Anytime you have minus and negative, you switch it to a plus. So I just do a same change opposite and leave it. I need to get y by itself. In order to do that, yes, sir.
You add the 4 to the other side.
I do, but what do I have to do first?
You have to
I have to do that. Yes, this whole thingy, distributing. Do that first. Okay. So I will suggest you guys draw your arrows for the distributed property because you'll forget the second term. You get -2x minus 6. And now, like you said, you do what with that?
You add the 4 to the 6.
Is it a 6 or a -6?
The -6, you add that, and you get y equals -2x minus 2.
I agree. Good work. Sure. You gonna play it for parents later?
No.
No, you're not.
For mine.
Don't BS me. Sometimes. Point slope form.
You're just always laughing, that's why.
You know what? If you don't enjoy what you're doing, why are you doing it? Right? I mean, so make the most of it, right? Have a little bit of fun with it. Okay? Yes, sir.
My God, I can't.
Okay. Try one more, then I'm gonna show you the other thing. Whoa. Slope. We'll say it's 1/2, and our point will be at -4 and 1. I want you to write the equation of the line that has that slope, and it goes through that point, which means you'll start with point slope form and then solve for y. Yes, ma'am. Oh, I think your hand went up. Brian, be quiet. So remember, you're always going to put your final answer into slope intercept form, but what you want to do is you use point slope form to get there. Okay? That's what I want you guys to think of. No decimals. So remember, it's a lot of direct substitution. I will suggest write out the formula and go on your merry way. Yes, ma'am.
So, if the x is negative, can you just put in parentheses +1?
Exactly what you should do. Yeah. Yep, that's fine. So you get y minus 1 is 1/2 x plus 4. Distribute through. And then add 1. And you're done.
Wait. I got something else.
Yeah, don't use decimals. You always use fractions. Yeah, you multiply. distributing and multiplying. All right. Now, worst case scenario. Write the equation of a line that has 2 points. When you have to write the equation of a line that has 2 points, what do you think you got to figure out first? The slope. Okay. So what happens here, this is going to encompass basically everything that you've looked at so far today. When you have to write the equation of a line that has, excuse me, that you write the equation of a line that has 2 points, you start by first finding the slope. So if you're writing out your ordered pairs of 2 and 4, 6 and 1, write down what they are. Write down what they are first. Then fill in all the blanks. Write your equation for slope. So first thing you do is find slope. Did you find slope? Okay, I'm not that far yet. Jeez. Find the slope, you get 1 minus 4 over 6 minus 2. What is that? Negative 3 over 4? You guys okay with that? Negative 3/4?
Yeah, it's good to me.
So now there's your slope. Now you have 2 points. Does it matter which one you choose to work with point slope? Nope. My suggestion, since now you're going to use point slope, which one do you already have written out as x sub 1, y sub 1? The 2 and 4. Since it's already written out in terms of sub 1, sub 1, might as well just reuse it. That way you can use that formula straight up. You reuse the slope you found with your x minus 2 and y minus 4. Okay. Now, when you're using that multi-view calculator, it allows you to put fractions times stuff. And that's kind of an important thing. Okay. Let's see. I got negative 3 over 4 times negative 2. Did you get 3 over 2?
I just got that.
Okay. No, there are no such thing as decimals. Decimals are gone. Yeah. Fraction button, the n over d. And then what do I have to do to that? Add 4. So what's nice is that even on this calculator, you've got that 3 over 2 right now stored. If you hit plus 4, it'll carry the fraction over. And that's your answer.
I didn't get
Because you. Yeah. Yeah. If you didn't get the fraction, you hit the double arrow and go from there. Okay. So what you're looking at today is really just slopes. Write the equation of lines, and write the equation of lines having to use your slopes to get there. It's all kind of the same stuff over and over and over and over again. I think I have. Do I do one more of these real quick?
No.
Yes.
You're more than happy to do one more. Oh, like it'll take you that long. Advocate, I like it. Write the equation of the line that contains those 2 points into slope intercept form, please, and thank you. I think Okay. What's up? Yeah, that doesn't matter. Yeah, when you have negatives, guys, in fractions, when your slope 6, we'll run out of time. 6 minus 4 over -2 minus 0. You get 2 over -2. What's 2 over -2? -1, isn't it? But if you happen to have fraction form with that, the negative tends to float to the top. Okay? The negative will tend to float to the top, and that's fine. And then just pick out a point. Hey, which were those 2 points to be easier to work with?
0 and 4.
0 and 4. 0 and the 4 would be, because then you get y minus 4 is -1 times x minus 0, which is y minus 4 equals -1x. Y equals -1x plus 4. Good. This is a lot of review today. We're going to do this through like that. On the calendar, I think I already put it. It's page 175, I think.
Hey,
Maybe.
175.
I think it is. No, I'm sorry, not 175. I'm on the wrong thing. How about page 194? That sounds better. Numbers 13 through 15, and then 24 through 32 even. So it's a total of 8 problems, ladies and gentlemen. I want you to do. Sorry, give it away. I want you guys to do the first 3 are just find the slopes. Then the last 5 are just a mixture of writing equations of lines, whether it's the slope-intercept form, point slope, point to slope, or 2 points. Okay? Go from there. We will talk about these more tomorrow, then we'll start doing graphing and more fun times of this. My best guess is we'll be testing this Thursday, Friday, sometime next week. Yes, ma'am.